Hi everyone, welcome back to another video. In this particular video, today we're going to be solving EDEXCEL IGCSE Chemistry Unit 4CHO/4CH1. Today we're going to be solving paper 1CR for June 2016. We'll solve the entire question paper in this video. The periodic table is shown on page 2. In the periodic table, which number increases from 3 to 10 in period 2? So from 3 to 10, we have an increase in atomic number. In the periodic table, which number increases from 9 to 226 in group 2? It is the relative atomic mass. An atom of boron contains proton, neutrons, and electrons. Use the words from the box to complete the sentences. The particles with the smallest mass are electrons. The particles with negative charge are electrons. Two types of particle in the nucleus of boron atom will be protons and neutrons. In boron atom, there are equal number of electrons and protons because they say atom is neutral. The element boron has isotopes. These isotopes have different number of neutrons. In chemistry, the state symbol S, L, G, and aqueous are often used. Complete the table to show the state symbol before and after the change. Water boils in a kettle, so it is a liquid that is changing into gas. Ethene is converted to polyethylene. Ethene is a gas and polyethylene is a solid. Crystal of iodine sublime on heating. So iodine crystals are solid and subliming on heating causes it to become gas. Some marble chips are added to the solution of hydrochloric acid. Complete the equation for the reaction that occurs by writing the appropriate state symbols for each formula. Calcium carbonate solid reacts with hydrochloric acid, which is aqueous, and to produce a calcium chloride salt, which is aqueous, the water that is produced will be liquid and the CO2 gas produced will be gas. Which state symbol is used most often for the elements of the periodic table at room temperature? The elements of the periodic table are mostly solid. So S is used. Guys, as an interesting note, there are only two liquids in the periodic table at room temperature and pressure, and they are bromine, which is from the non-metal, and from the metal there is mercury. Techniques used in the separation of mixture include crystallization, filtration, fractional distillation, and simple distillation. So for each separation, select the most suitable technique. Pure water from seawater. So we can do simple distillation. Ethanol from a mixture of ethanol and water. Since there is a boiling point difference, 78 degrees Celsius for ethanol and 100 degrees Celsius for water. So fractional distillation. Calcium carbonate from a mixture of calcium carbonate water. Calcium carbonate is a solid and water is a liquid. So filtration will be the process. Hydrated copper sulfate from CuSO4 aqueous. So since we want to get hydrated copper sulfate, that's why we'll have to do crystallization. The table gives information about some of the elements in group 7 of the periodic table. What is the color of chlorine at room temperature? We can see the color becomes darker down the group, so the color will be in between yellow and red brown, so it could be green. The trend in the boiling point for these elements is similar to the trend in melting points. Predict a value for the boiling point of iodine. So iodine can have a boiling point which can be around 80 degrees Celsius above, because from here to here we can see there is almost 130, and from here to here we can see there is a difference about 60 plus 95 degrees. So we can expect another 95 degrees in increase in terms of boiling temperature. So around 170 180 will be a correct answer. Guys, the mark scheme had a temperature range between 120 to 215, so feel confident when doing this answer. Astatine is another element in group 7. Predict its color and physical state at room temperature. Iodine is already a solid, so below iodine is astatine. So the color will be black definitely, and physical state is definitely going to be solid. The elements in group 7 have similar chemical reaction because they have same number of outer electrons. It is the outer electrons that determine the chemical reactivity of a particular substance. So when there is similar outer electrons, they will have similar chemical reactivity. A student wrote those statements about the reactions of the group 7 elements. The reactivity of the elements decreases down the group. It is a correct statement. The elements form ions with a single positive charge. No, it forms ion with a single negative charge. For example, Cl-. The formula of astatine molecule is 82. Yes, group 7 molecules are diatomic. The equation for the reaction between chlorine and potassium bromide This equation shows sodium bromide instead of potassium bromide. It's supposed to be KBr, so this is a wrong statement. In the reaction between bromine and potassium iodide, bromine acts as a reducing agent. The bromine accepts electron. So in the reaction between bromine and potassium iodide, we can see the reaction Br2 plus 2Ki producing 2KBr plus I2. Iodine loses electron. Loss of electron is oxidation. Bromine accepts those electrons that is lost by iodide ions. So bromine is acting as a oxidizing agent by reducing itself. So it gets reduced. However, it is the oxidizing agent. 3 of the statements contain one incorrect word. So the incorrect word, first of all, will be the positive charge, and the correct word will be negative. Then for the second one will be, instead of potassium, it will be sodium. And the last one will be, instead of reducing, it will be oxidizing. A student investigates the pigment found in some vegetables and fruit. She obtains some colored vegetables and fruit extracts from carrot, tomatoes, and sweet potatoes. She places a spot of each extract on chromatography paper along with spots of 3 pigments, beta-carotene, chlorophyll, and lycopene. Her teacher provides a solvent containing volatile flammable organic compounds for the experiment. The diagram shows the apparatus for the start of the experiment. So we can see the lead, tank, starting line, and then solvent. Okay, so explain why it is important for the solvent level to be below the spots. We have the solvent below the spots so that the solvent does not wash away or dissolve away the spots, or the fruit extracts, pigments. State 2 potential problems that are prevented by fitting the tank with the lead. The solvent used in this particular experiment is highly volatile, so it will prevent the evaporation of that solvent. The second thing about the solvent is that the solvent is highly flammable, so there will be a risk of fire. And the third thing is that the fumes of the solvent can be toxic or poisonous, which can harm a student. The diagram shows the chromatogram at the end of the experiment. Which 3 of the statements A, B, C, D, and E are supported by the chromatogram? Place a cross in 3 boxes to indicate your choice. Chlorophyll is not present in carrots, sweet potatoes, or tomatoes. So chlorophyll is indicated by P2. So this is P2. And we can see that none of them, it is a correct statement because none of them, V1, V2, or V3, consist chlorophyll. Beta-carotene is present in carrots but not present in tomatoes. So beta-carotene is P1. And we can see beta-carotene is present in both V1, V2, and V3. So this will be a wrong statement. Both beta-carotene and lycopene are present in sweet potatoes. Lycopene is represented by P3. And P3 is present in all of them. So this is a correct statement. Lycopene is present in tomatoes but not present in carrots. I've seen lycopene is present in V1, V2, and V3. So both carrots and tomatoes contain pigment other than beta-carotene, chlorophyll, and lycopene. Yes, there are other pigments, for example, this one and this one. And V3 consists of this particular pigment which is not even soluble in the organic solvent. One of the pigment present in the vegetable extract is not shown in the chromatogram. It appears as very faint spot 1.3 cm above the starting line. Calculate the RF value using the expression. So to calculate the RF value, we'll have to calculate the distance traveled by solvent. In your paper, you will have to measure the distance from the start line up until the solvent front. The value is 6 cm. Now to calculate the RF value, the distance traveled by the pigment is 1.3. Distance traveled by the solvent is 6, so the RF value is 0.22. Suggest a reason why there is a spot on the starting line in the chromatogram for sweet potatoes. There is a colored substance in sweet potatoes that does not dissolve in the solvent, in the organic solvent. Hydrogen chloride is formed in the reaction between hydrogen and chlorine. The equation for the reaction is hydrogen reacting with chlorine to produce hydrogen chloride. Each molecule in this equation contains the same type of bonding. Name the type of bonding. So we can see that these particular molecules are all nonmetals and they are forming covalent bonding. The bonding in hydrogen molecule is strong. Explain why the boiling point of hydrogen is low. In hydrogen molecule, there are weak intermolecular forces between the molecules. atoms. Therefore, a very little amount of heat energy is required to overcome that intermolecular force and separate the molecule. Explain how the two atoms in chlorine molecules are held together. So there is a strong attraction between the bonding pair of electron and the nuclei of the both atoms that shared the electron. Draw a dot and cross diagram to show the bonding of hydrogen chloride molecule. This diagram can be drawn in two ways. For example, hydrogen with a dot and chlorine with a cross. Then we'll have to represent all the other outer shell electron for chlorine. The other way we can represent it is by drawing circles. When drawing circles, we must remember that the overlapping portion is the only portion where we're going to be showing the shared pair of electron. Hydrogen chloride gas dissolves in water to form solution A. Hydrogen chloride gas dissolves in methyl benzene to form solution B. Our teacher adds a piece of magnesium ribbon to each solution. Explain why she observes effervescence with solution A but not with solution B. The effervescence is produced due to hydrogen gas. Solution A is acidic, so it contains hydrogen ion, which produces hydrogen when reacting with magnesium. The solution B is not acidic and thereby does not contain hydrogen ion because the hydrogen chloride gas is dissolved in methyl benzene, where it is unable to dissociate or ionize into hydrochloric acid. The table shows the displayed formula of some organic compounds. We can see methane, propane, B is propane and B is propane and C is propane, D is butane, E is also butane but it's actually butane, and F is cyclobutane. Explain why all of these compounds are described as hydrocarbons. So whenever we are asked the question that why a particular compound is called hydrocarbon, we'll always answer with this particular statement. Because these compounds contain only hydrogen and carbon atoms only. The word only will carry our second mark. Why are B and E described as unsaturated? Whenever there is a carbon-carbon double bond, we can describe them as unsaturated. Which letter represent the first member of the homologous series of alkene? We can see methane is the first, so it's A, represented by A. Which letter represent compound that have the empirical formula CH2? Alkenes have a empirical formula of CH2. There are two alkenes present here. One is butene and the other one is a propane, so B and E. The other CH2 empirical formula will be produced by cyclobutane because it contains 4 carbon and 8 hydrogen. So we'll say B and E and F. Compound F has the same general formula as an alkene. Why F does not decolorize bromine water? If we look into compound F, we see that F does not contain any carbon-carbon double bond. One of the compounds in the table reacts with bromine to form G, a compound with the composition by mass C22H3.7 Br74.1. We need to show the empirical formula by calculation. To do this particular empirical formula calculation, first of all, we will divide the percentage with relative atomic mass. Once we divide it with relative atomic mass, then we will get the number. For the carbon, we get 1.85, for hydrogen 3.7, and for bromine 0.93. Then from these numbers, we'll choose the smallest number, which is 0.93, and divide all of them by 0.93. Then the simplest whole number ratio that comes for the carbon is 2, hydrogen 4, and bromine is 1. So the empirical formula becomes C2H4Br. The relative formula mass of G is 216. Deduce the molecular formula of G. First of all, we'll find out the MR of the empirical formula. Once we find out the MR of the empirical formula, the answer comes 108. Then we will find out by dividing 216 with 108, we'll find out a number, which in this case it's 2. Then to find out the molecular formula, we'll multiply the empirical formula with this 2, which gives us C4H8Br2. Neodymium is a metal used in powerful magnets. One stage in the extraction of neodymium from its ore is to heat neodymium fluoride with calcium. The table shows the melting point of the substances in this stage of the extraction. So we have calcium, calcium fluoride, neodymium, neodymium fluoride, and our melting points are provided. Balance the equation for this reaction. Since there are 3 fluorines, and there are 2 fluorines on the right hand side. So we can multiply this by 2. This gives us 6 fluorine in the left hand side, and we can multiply this by 3, which gives us 6 fluorine on the right hand side. And then there are 2 neodymium in the left hand side. So we'll put a 2, all right, to balance the neodymium. And on the right hand side, there are 3 calcium. So we'll put a 3 in front of the calcium Ca. At one point in this extraction, the temperature of the reaction mixture is 1100 degrees Celsius. Which two substances are solid at this temperature? At this temperature, we will definitely have calcium fluoride and neodymium fluoride as solid. Suggest the most likely type of bonding present in neodymium fluoride. So neodymium is a metal, so the type of bonding present will be ionic. Neodymium reacts with oxygen to produce neodymium oxide. Suggest the formula of neodymium oxide. In order to do the formula for neodymium oxide, we can look into this particular formula where the neodymium has a oxidation state of Nd3+. So neodymium oxide will be similar to that of aluminium oxide, Nd2O3. The diagram shows the particles in neodymium. We can see the neodymium is regularly arranged with electrons in between. Explain with the reference to the diagram why neodymium is malleable and good conductor of electricity. The neodymium ions are arranged in layers. They form layers which can slide over each other, and the delocalized electrons can travel and flow through the structure when voltage is applied. That's why it can carry electricity, and because it is regularly arranged, that's why it is malleable. A student investigates the reaction between acids and alkalis. He uses this apparatus to measure the temperature change in the reaction between dilute hydrochloric acid and aqueous sodium hydroxide. You can see the experiment is set up using polystyrene cup to prevent heat loss. This is his method that the student has used. Add 25 cm³ of dilute hydrochloric acid to the polystyrene cup and record the steady temperature. Once the steady temperature is reached, then add some aqueous sodium hydroxide and stir the mixture. The student then records the maximum temperature of the mixture. The student repeats the experiment using different volume of aqueous sodium hydroxide. What is the advantage of using polystyrene cup rather than glass beaker? So polystyrene cup is a very good insulator. Thereby, it can reduce the heat loss to surrounding. These are the thermometer reading for one experiment. Before adding aqueous sodium hydroxide and after adding aqueous sodium hydroxide, we can see the reading. So temperature before adding, so 15.9, and temperature after adding the sodium hydroxide, we can see 16, 17, 18, 19, 19.4. So the change in temperature is 3.5 degrees Celsius. The table shows the result of some experiments. The initial temperature of both solution in the experiment is 17.6 degrees Celsius, and we can see the volume of sodium hydroxide used. The maximum temperature reached was when we had 20 cm³ of sodium hydroxide used, and it was 23.8. Plot this result on the grid. Draw a line of best fit through the first 4 points and another line of best fit through the last 3 points. Extend both of the lines so that they cross each other. For the points where the line crossed, write down the temperature of the mixture and the volume of aqueous sodium hydroxide in cm³. To do that, first of all, what we're going to do is we're going to extrapolate. So the maximum temperature rise is 21, 22, 23, 24, 24.3, and the volume in which it occurs is 17 cm³. In a similar experiment using different acid and alkali, the student records this result. The volume of dilute sulfuric acid 25 cm³, the volume of aqueous potassium hydroxide 22.7, initial temperature of the solution 18.9, final temperature 24.7. Calculate the heat energy for the change during this reaction using this equation. We will assume that 1 cm³ represents 1 gram. Because we have two volumes that are added together, so we need to find out the total volume. Once Once we find out the total volume, then that will be equals to the total mass. Now after that, we're going to find out the temperature change. The temperature change will be 24.7 minus 18.9, which gives us a value of 5.8 degrees Celsius. Then we're going to use the formula mass, which is 47.7 multiplied by 4.2 times temperature change, which is 5.8. This will give us an approximation of 1200 joules. The reason why we're going to write 1200 joules because we're supposed to give our answer in three significant figure, and when we make 1160 or 62 into three significant figure, then it turns into 1200. Sodium thiosulfate solution and dilute hydrochloric acid reacts together slowly to form a precipitate of sulfur. This precipitate eventually makes the mixture go cloudy. Thus, a student uses this method. Place 20 cm³ of sodium thiosulfate solution and 20 cm³ of water in a conical flask. Add 10 cm³ of dilute hydrochloric acid to the flask. Place the flask on a piece of paper marked with black X. Time how long it takes before the X can no longer be seen. So the student places the I over here, conical flask, sodium thiosulfate solution, and paper with the X marked on it. Sodium thiosulfate reacts with the hydrochloric acid to produce sodium chloride, water, sulfur, sulfur dioxide. Before starting her experiment, the student considers the risk to her of sulfur dioxide escaping from the flask. She uses this information. Concentration of sodium thiosulfate 0.3 mol per dm³, volume of sodium thiosulfate 20 cm³, volume of water 20 cm³, volume of hydrochloric acid 10 cm³. Calculate the mass of sulfur dioxide formed in this experiment. The hydrochloric acid is in excess. In order to calculate the number of moles of sulfur, first of all, we'll have to find out the number of moles of sodium thiosulfate. Here the concentration is given 0.3 mol per dm³, which will be multiplied by the volume, which is 20 divided by 1000, because the 20 cm³ is given in cm³. Then we will find out the number of moles, which is 0.006 mole. Then we will convert it into number of mole of sulfur dioxide. The number of mole of sulfur dioxide is equal to the number of mole of sodium thiosulfate, so it's gonna be 0.006 mole. Then we're gonna find out the MR of sulfur dioxide, which is 32 plus 2 into 16 equals to 64. And then we're gonna find out the mass of sulfur dioxide, which is 0.006 times 64 equals to 0.38 grams. So the experiment produces 0.38 gram of sulfur dioxide. The solubility of sulfur dioxide at room temperature is 100 gram per dm³. Use this additional information to explain whether any sulfur dioxide gas escapes from the flask. The volume of solvent is 50 cm³, which would dissolve 100 divided by 20, which is equals to 5 grams. So 150 cm³ will be able to dissolve 5 grams of sulfur dioxide. 0.384 or 0.38 gram of sulfur dioxide that is produced is less than 5 grams. So no sulfur dioxide would be able to escape. At what point in the experiment should the student have started a timer? Once the hydrochloric acid is added to the sodium thiosulfate, the student should start the timer. She repeats the experiment using the same volumes and concentration of solutions but different temperatures. The graph shows her results. Temperature in degrees Celsius and time in second is represented in y-axis. The results at 1442 is anomalous. Explain one mistake the student may have made to cause the anomalous result. The student may have started the timer too early, or the thermometer scale was read incorrectly by the student. Both of these could lead to this particular point, anomalous point. Use the graph to find the time taken for the X to be no longer seen at 35 degrees Celsius. At 35 degrees Celsius, if we extrapolate, then we get time in seconds, which is 20. However, it is slightly lower than that. So we can take it 20 because it's close to 20. The student repeats the experiment using nitric acid in place of hydrochloric acid. She records the time for the X to no longer be seen, then uses the times to calculate the rate of reaction at each temperature. The graph shows the results she plots. Relative rate in per second suggests two reasons why the results are least accurate at high temperature. At high temperature, the time taken for the reaction is very short and the heat loss to the surrounding is very great. So this gives anomalous result or least accurate result. The student wrote this explanation for the shape of the crown. As the temperature increases, the rate of reaction increases. This is because there are more frequent collisions between particles of reactants. Use the particle collision theory to explain another more important reason for the increase in reaction rate. So as the temperature increases, more number of collision occurs between the particles, and the particles collides with more energy or greater energy than the activation energy. Therefore, there are more successful collision per second, which leads to faster reaction. Another student uses the same reaction to investigate the effect of changing the concentration of sodium thiosulfate solution on the rate of reaction. Give three variables that the student must control in this investigation to obtain a valid result. The student must keep the concentration of the hydrochloric acid same in all experiments. The volume of hydrochloric acid should be same in all experiments. The total volume of sodium thiosulfate solution along with the water should be same in all experiments. And also, most importantly, the temperature, since temperature affects the rate of reaction, should be same in all experiments, and the temperature can be maintained by using a water bath. The flow diagram shows how a fertilizer is manufactured from the raw materials: air, natural gas, water, turned into carbon dioxide, hydrogen, nitrogen, and oxygen. Then it reacts to produce ammonia, which then is converted into nitric acid, and then it's converted to ammonium nitrate. The hydrogen needed is formed in two reactions. Reaction 1 occurs between steam and methane in natural gas. Balance the equation for this reaction. 1 carbon is supposed to produce 1 carbon monoxide, but 4 hydrogen is going to produce 2 hydrogen. However, since we also have 2 hydrogens from here, so the total number of hydrogen will be 3 molecules of hydrogen. The equation for the reaction 2 is carbon monoxide reacting with water, steam, producing carbon dioxide gas, and hydrogen. Del H of this particular reaction is negative 41 kJ per mole. Assuming that this reaction reaches equilibrium, explain what happens to the yield of hydrogen if the reaction is carried out at a higher pressure than at the same temperature, If we look into this particular equation, there are two moles of reactant in the left-hand side, and there are 2 moles of product on the right-hand side. So increasing pressure has no effect on the yield because there are equal number of moles on each side. Assuming that this reaction reaches equilibrium, explain what happens to the yield of hydrogen if the reaction is carried out at a higher temperature but at the same pressure. Since the forward reaction is exothermic, if we carry out this particular reaction at a higher temperature, then the backward reaction will be favored. So we can write down the answer in this way. At higher temperature, equilibrium position shifts to the left, so yield of hydrogen decreases. Because the forward reaction is exothermic, that's why high temperature favors the backward reaction. Reaction 2 can be represented on an energy profile. Complete the profile by showing the products of the reaction and the enthalpy change for the reaction. Because the reaction is exothermic, so the product will be at a lower level than that of the reactant, and the del H will be indicated from the level of the reactant to the level of the product. Reaction 2 is carried out using a iron oxide catalyst. State the effect, if any, of using a catalyst on the enthalpy change for the reaction. Catalyst has no effect on the enthalpy change because the amount of energy given off in a particular reaction does not change because of catalyst. Explain how a catalyst increases the rate of a reaction. Catalyst increases the rate of the reaction by providing an alternative pathway with a lower activation energy. The equation for some other reaction used in the manufacture of ammonium nitrate are: reaction 3, nitrogen and hydrogen reacts together to produce ammonia. Reaction 4, ammonia reacts with oxygen to produce nitrogen monoxide and water. Reaction 5, nitrogen dioxide turns into N2O4. Reaction 6, ammonia reacts with nitric acid to produce ammonium nitrate. Explain which of these are redox reaction. In reaction 3, there is a gain of hydrogen. Gain of hydrogen is reduction. So thereby this is a redox reaction. In the reaction 4, there is a reaction with oxygen, so the reactant molecule gains oxygen, so that is a oxidation. Reaction 5 and reaction 6 does not represent any oxidation reaction. Reaction 6 is neutralization and reaction 5 is like reformation. So Reaction 3 and 4 are redox reaction. In reaction 3, there is a gain of hydrogen, and in reaction 4, there is a gain of oxygen. The manufacturer produces a batch of 34 kg of ammonia. Calculate the maximum mass of ammonium nitrate that can be made from this mass of ammonia using reaction 6 in part D. So we can only use the reaction 6. To do this particular answer, at first we're going to write down the reaction of ammonia reacting with nitric acid to produce ammonium nitrate. And we will find out that the reaction is 1:1:1 ratio. Then we will find out the number of moles of ammonia. So we have 34,000 grams of ammonia. So we'll divide it by 17, which is the MR of ammonia, and the answer is 2000 moles. Then we're going to find out the MR of ammonium nitrate, which is 80. Then we're going to find out the mass of ammonium nitrate by multiplying the 80 with 2000, which will give us 160,000 grams or 160 kilograms of ammonium nitrate. The production of polymers from crude oil involves several processes, including fractional distillation, cracking, purification, polymerization. Three of the fractions obtained from fractional distillations are fuel oil, gasoline, and kerosene. Identify which of these fractions has the darkest color. Guys, the longer the chain of carbon length, the darkest the color is going to be. So gasoline has the shortest chain, thereby it will have the lightest color, and fuel oil has the longest chain, so it will have the darkest color. Identify which of these fraction has the highest boiling point. So longest carbon chain containing lengths are going to have the highest boiling point, and thereby fuel oil will be the answer. Identify which of this fraction contains molecule with the fewest carbon atoms. Gasoline has the shortest carbon chains. Cracking involves heating some of the fractions to above 650 degrees Celsius. Name a catalyst used in industry for cracking. So in the industry, aluminium oxide is used, which is commonly known as alumina. One reaction that occurs in cracking involves the conversion of one molecule of hexadecane into one molecule of octane and two molecules of an alkane. Complete the equation for this reaction. So we can see the octane already there. Total number of carbon is 16. Since it produces two molecules of an alkane and we already have 8 carbons produced in the octane, so it can produce two molecules of C4H8. Guys, once we write this, it is very important to count the number of carbon and match it with the left-hand side and the number of hydrogens. Give 3 reasons why cracking is carried out. There is a greater supply of long-chain hydrocarbons than needed, but there is a higher demand for the short-chain hydrocarbons. There is also a higher demand for alkene to make polymers. When cracking is carried out, it produces shorter chains and also produces alkenes in large quantity. One of the compounds sometimes present in crude oil has the formula C6H12S. Explain why it is important to remove the compound from a fuel. When C6H12S is burned, then it produces sulfur dioxide, which causes acid rain. Acid rain damages trees, kills fish, causes respiratory, it acts as a respiratory irritant. It triggers asthma attack in some people. One compound obtained from crude oil is used as a monomer in polymerization. It has the displayed formula as shown. You can see the molecule propene. Complete the following structure to show a part of the polymer formed from this monomer. To do the polymer beforehand, we will do the carbon-carbon double bond. We will see that there are 2 hydrogens in one of the carbon, and other carbon has a hydrogen and a CH3 group. Then we will repeat this without the double bond. Guys, that's all for this particular question paper. Thank you for watching the video. Guys, question paper like this will be uploaded almost every day, so keep an eye for the next question paper as well, and I will try to put all of this particular question paper in a playlist. Guys, thank you for watching the video. Best of luck for your exam. See you in the next video. Bye bye.